Hello everyone. Today we're going to be working on section 10.2. We're going to be continuing graphing rational functions. The main difference between today and the last section is that we are going to be working with more complex rational functions, whereas in the first section we dealt with simple rational functions. So there's three important rules that you're going to need to know for this section. Please make sure you write these down in your notes. That way you can refer back to them on your homework and when you study. So the first thing is, if we're going to be looking for the x-intercepts, in order to find the x-intercepts, all you have to do is set the numerator equal to 0 and then solve for x. So just remember the x-intercepts are where they hit the x-axis. So another name for these would be your roots or your zeros. Okay, and we've talked about those different names before in class. The vertical asymptotes, remember the vertical dotted line, is going to be found by setting the denominator equal to 0 and solving for x. Okay, so x-intercepts is the top. Vertical asymptote is the bottom. And then the more complex part of this section is the horizontal asymptote. So you have to look at two things in order to find the horizontal asymptote. You have to look at the degree of the top, which is m, and then the degree of the denominator, which is n. And m and n are just letters they give. The letters really aren't as important. But there's three main rules when you're looking at the degree of the top versus the degree of the bottom. And you want to write these down. The first is, if the degree of the top is less than the degree of the bottom, then y equals 0. Okay, if the degrees are equal, so maybe the top degree is 5 and the bottom degree is 5, then what you're going to do is have y equals a fraction, and that fraction is one coefficient over the other, so the leading coefficient, so a over b. Okay, and then if the top degree is greater than the bottom degree, there are no horizontal asymptotes. So these three rules you're going to want to make sure you write down and that you study, so that way you're prepared for your quizzes and tests. So what I'm going to do today is just go through three basic examples of graphing these rational functions, and then you guys should be good to go. So here's our first example. It says graph the equation y equals -12 over x to the fourth plus 4. So not only are we going to graph, but this one also asks you to state the domain and range. Okay, so we're going to practice that today. But what I want to do on these problems is go through the first three steps of finding the x-intercepts, vertical asymptote, and horizontal asymptote. And then once I have those three things established, then I can make a table and plug in some points. So let's look and see if there are any x-intercepts. So remember, to find the x-intercepts, you just have to set the top equal to 0. So I'm going to say -12 equals 0. Well, if you look at this, there's no x's to solve. And does -12 equal 0? No, it doesn't. Okay, so that doesn't work. So that means there are none. Okay, that means it's not going to hit the x-axis. Okay, so once we know that, we can move on to step 2. So step 2 is to find the vertical asymptote. Oops. So to find the vertical asymptote, remember we set the denominator equal to 0. So we're going to have x to the fourth plus 4 equals 0. So if I want to start solving this, I'm going to subtract 4 over to the other side. And I get x to the fourth equals -4. Well, is there something to the fourth power that will get us a negative number? Well, in this case, no. Okay, so even if I took the fourth root of both sides, which we practiced in a previous chapter, I'd get x equals the fourth root of -4. Well, there's nothing to the fourth power to ever get us a negative, okay, because even powers always give us positive answers. So this means there is no vertical asymptote, because these would give us imaginary answers. Okay, so we have no x-intercepts and no vertical asymptote, which is perfectly okay. Sometimes that happens. And then we move on to the last one, which is our horizontal asymptote. So remember, for the horizontal, you have to look at the degree. So I'm going to look at the degree of the top. So the degree here of the top is 0, because there is no variable. Okay, and then the degree of the bottom is our highest exponent there, which is 4. So what that means in this case is that, using our letters, m was 0, n was 4. Okay, and we had a rule that said when the m is less than the n, okay, so 0 is less than 4, that means that we have a horizontal asymptote at y equals 0. So what I'm going to go ahead and do is graph a dotted line at y equals 0. That's our horizontal. Okay? So now that I've established these three things, now I can just go ahead and make a table of values, and I can plug in some points. And what points you pick will just be kind of dependent on the graph that you're working with. There's no vertical asymptote, so you can pick any positive or negative numbers. So I'm going to pick a variety of both, just to make sure we hit all sides of the graph. So I'm going to plug in something like -4, -2, 0, maybe 2 and 4. And they don't have to be these numbers. You could pick -6, -1, 3, it doesn't matter, as long as you have a variety of points. So if I plug these in here, I'm going to get -12 over -4 to the 4th plus 4. Now please make sure if you're typing this into your calculator that you're using parentheses around that negative. Okay, otherwise your calculator will calculate it incorrectly. So when we do that, we end up getting, let's see, -0.05. So -0.05. Okay, if I plug in -2 into that, so I'll do that really quickly in the calculator, then we're going to get -3/5 or -0.6. Okay. If I plug in 0 into my equation, okay, that one's a little easier because plugging in 0 into this, everything here is going to cancel, so I'll get -12 over 4, which is -3. Okay. If I plug in 2 into my equation, notice I'm just taking out the x and plugging different numbers in. Okay. I'm going to get -12 over 2 to the 4th plus 4. That's going to get us -3/5 again, so -0.6. Okay. And then if I plug in 4 into this equation here, I'm going to get the same thing as I did when I plugged in -4. So this one works out. It's very symmetrical. I'm going to get -0.05 again. So now I can go ahead and plot these points. And if you don't like the points that you've gotten, pick something else. Plug in 1 and 3 and maybe -1 and see what you get. So I'm going to start with the 0, -3. So 0, 1, 2, 3. So there's my point there. When I plug in 2, I get -0.6. So right about there. Okay. When I plug in -2, I get -0.6. Okay. When I plug in 4, I get -0.05. So it's extremely close to the dotted line. Okay, I can't even graph it as close as it really is. Okay, just do the best you can. So here's our graph. Okay, and then like I said, if you want to plug in something like -1 or 1, okay, maybe if I plug in 1 there, let's see what we get. We might get a little bit of a nicer number. Okay, so if I plug in 1 into this equation, I get -12 divided by, 1 to the 4th is 1, so -12 divided by 5, so it gets us -2.4. Okay, whoops. So at 1 I get -2.4, so right about there, which means at -1 it'll also be -2.4. That gives us a little bit more of an idea of what the graph is going to look like, and then I can just go ahead and connect my points. So I'm going to curve this here. Now notice there is a horizontal asymptote, which means I can't cross that. So it's going to get really close to that dotted line, but never actually touch it. Okay, so then it flattens out. There we go. Okay, so obviously it's not the greatest. I had trouble connecting it, but it's going to be this curved graph that goes all the way down to -3 and then comes back up, getting really close to that dotted line, but then flattening out. So we've got our graph now, and then it says to state the domain and the range. So if I want to look at the domain, remember, that's the x's. Well, what kind of x's can I pick? Well, I picked positives and negatives. There was no restrictions left to right. So my domain for this graph would be all real numbers. Okay, my range, however, has some restrictions because what's the lowest this graph goes? Well, the lowest my whole graph goes, if I follow it around, is -3. So my lowest is going to be from -3. And it does hit at -3, so my y is going to be greater than or equal to -3. But less than what? Well, my horizontal asymptote tells me it can't cross 0, so it's going to be less than 0. Okay, because my graph won't go above that dotted line. And notice it's not less than or equal to because it will never actually hit the 0, okay, because it can't cross or touch that dotted line. So there's my domain, there's my range, and then we'd be done. So let's try example 2. Example 2 is a little bit different because now we've got two different types of equations on the top. We have an x squared and an x squared. So I'm going to go through my process again. So step 1, find the x-intercepts. So I'm going to set the numerator equal to 0. So x squared minus 4 equals 0. So now I can go ahead and solve, adding 4 to the other side. I get x squared equals 4. And then I take the square root of both sides and I get x equals positive and -2. So I actually have two x-intercepts here. I have one at 2 and one at -2. So I'm going to go ahead and plot those points right away. So here's my x-intercepts. Okay. Then in step 2, I'm going to find my vertical asymptote. And remember, that's to set the denominator equal to 0. So x squared minus 1 equals 0. So if I solve this, I'm going to add 1 to the other side and get x squared equals 1. take the square root of both sides and I get x equals plus or minus 1. So here I have two vertical asymptotes. And I'm going to draw those in. I'm going to draw them in blue. So one at x equals positive 1 and one at x equals negative 1. So it is possible to have more than one vertical dotted line, or possible here in this case to have one or none. Okay, so we've got two there. And then in step 3, I'm going to find my horizontal asymptote. So remember, that's looking at the degrees. So the degree of the top is 2 and the degree of the bottom is 2. So in this case, m is equal to n. So we said we had this rule where we have y equals the first leading coefficient over the second leading coefficient. So 1 over 1. Okay, so in this case, my equation is y equals 1. So I'm going to draw a horizontal asymptote at y equals positive 1, and I'll do that in green. Okay, so this one has 3 dotted lines in it as well as our 2 x-intercepts. So this is going to help us guide where we can plug in some points. All right, so I'm going to go ahead and make my table just like I've done before. And when I make my table, I just have to make sure that I pick numbers to plug in that are on each side of my vertical asymptote. So I need to pick numbers to the left, in the middle, and into the right. So when I pick numbers to plug in, there's some numbers to the left, maybe would be something like negative 1.5, maybe negative 4. Okay, just make sure I have a couple points over on the left. And then I need to pick a couple in the middle. So maybe I pick negative 1/2, 0, and 1/2 to plug in. And then on the right side, maybe I pick the same kinds of points. Maybe I pick positive 1/2 and maybe positive 4 or 3. It doesn't really matter. Okay, so as long as I've got some points to the left, in the middle, and the right, then that's all I really need. So just to save some time, I went ahead and plugged in these x values into my equation, and these are the y values that I got out. So you want to make sure, especially with the negatives, that you try it in your own calculator and make sure you get the same answers as I did. Otherwise, you might have to check how you're typing them into your calculator. That's very important, especially when you're plugging in negatives, that you put parentheses around the negative number before you square it. Okay, so I'm going to go ahead and plot these points and then connect my graph. So at negative 1.5, I get negative 1.4, so right about there. And at negative 4, I get 0.8. So now I have 3 points over here, so I can connect them. Notice they never cross any of the dotted lines. Okay, that's very important. So this is going to have to stay just in this region. Then when I go to negative 1/2, I go up to 5. Plot a point. And at 0, I get 4. And at positive 1/2, I get 5 as well. So this one's going to be a U shape, never crossing the horizontal or the vertical asymptotes. Okay, so it looks kind of like that. And then over on the right side, when I plug in positive 1/2, I get negative 1.4, and then 4, I get 0.8. So this one happens to be symmetrical, but they won't always be, so just keep that in mind. Okay, so connect my graph. Oops. Make sure it hits your points, okay, and then you'd be done. So this is my graph of this rational function, and then we'd move on to the next problem. So here's our last example. This one, notice we've got a quadratic on the top and then just an equation of a line on the bottom. So same process, we're going to go through and find our x-intercepts. So I'm going to take the top and make it equal to 0. Now this is one where you're going to have to do a little bit of factoring or use the quadratic formula. It's up to you. But this one does factor nicely. So I'm going to have x and x, and then negative 4 and negative 1. Hopefully at this point factoring is getting a little easier. Then we can set each of these equal to 0. So let's see. When I solve this, I get x equals positive 4 for the first x-intercept, and adding 1 over, I get x equals positive 1. Okay, so there's our two x-intercepts. So at 1 and 4. Then I'm going to go ahead and find my vertical asymptote by setting the denominator equal to 0. So x minus 5 equals 0. This one's nice and easy. Add 5 over, we get x equals 5. So I'm going to draw my vertical asymptote at x equals 5. Okay. And then I go to my horizontal asymptote. Remember, we look at the degrees. So the degree of the top is 2, and the degree of the bottom is 1. So here we have that the top is greater than the bottom, so that means there is no horizontal asymptote. Okay, and that goes back to our rules from the very beginning. Okay, so Now we just have to go ahead and make a table of values. And because I only have one vertical asymptote, I just want to make sure I pick points to the left and to the right, and enough of them to get an idea of what my graph looks like. So I'm going to make my table with x's and y's. So I already have 2 points over here on the left, so maybe I just pick 2 or 3 more, just make sure we get a wide variety of problems. So maybe I plug in -2 and 0 and 3, just get a couple extra points over there, and then maybe you pick 2 or 3 on the right side. So maybe I pick 6, 7, and 8. All right, so you guys can go ahead and plug those numbers in and see what you get, and then all you have to do is connect. Just keep in mind that you cannot cross your line over the vertical asymptote. So the left side is going to have one connected graph, the right side is going to have the other. So pause the video, plug in your points, and see if you get what I get at the end. Alright, so if you look at my table, I plugged in these values. I also added a 10 in here just to make sure we had an extra point. But you should have gotten, excuse me, these same y values out, and I went ahead and plotted those in green, what I got. So what you should notice is that these kind of have curves to them, and you're not going to connect them. Remember, you cannot cross over that dotted line. So when I connect these, I'm going to start over here on the left. I'm going to connect my first green point, and notice these all have arrows at the end. They all go on forever. I'm going to come up, hit that top green point, and then curve back around to my x-intercept. And then because I can't cross over this, that just means I'm going to go down forever. Okay, so there's my first side. And then I'm going to jump over to the right side, starting at my first point. Notice it's going to be getting really close to the vertical asymptote, comes down to this green point, and then curves back up and goes up forever. Okay, so what I just drew in purple, that's my final graph of this rational function, and then we would be done. All right, so if you have any questions about the 3 different examples, make sure you ask. But really the most important thing is knowing the 3 rules from the beginning and how to use them, and that will help you get started when you're plotting these rational functions. And then of course making a table is always a good place to go because you can get a lot of information just by plugging in some points. All right, so that's it for today, and hopefully you are ready to go. Thanks for listening.